We are now starting our lightning talks. My name is Lori. I was one of the program committee members. I'm head of community at Percona, and you got to give it up to Benazar for putting on a stellar show yet again. I don't remember what number this is, but it is a freaking kick-ass way to start our KubeCon week. So without further ado, let's kick it off with running Kubernetes on your workstation with Kind and Podman with Alexan.
Thank you, folks. So now the rush starts. I have 5 minutes, so I'll be real quick, okay? I have a bunch of slides for you. I'm kidding, it's just this one. I'm talking about running Kubernetes on your workstation with Kind and Podman. If you were here yesterday, there was a talk from 2 colleagues of mine from Red Hat. They talked about Podman Desktop, the benefits of it. So I recommend you to watch the presentation again if you didn't watch it, okay? So let's go for the demo, because as Yoda says, show me the code you must, right? So, Podman Desktop, this is the interface that you're going to use. Right here, you have a bunch of options, okay, to create lightweight Kubernetes clusters. You can create Minikube. Soon, you can create Microchip as well. But right now, we have these options here. And out of these options, I selected Kind. Why? Because this is a lightweight cluster, and it has this concept of installing a cluster using container as a node, okay? And also, it's real quick to spin up a cluster, and to put your application to work with it. Using Podman Desktop as the GUID, you're going to see that it streamlines the process for you. You don't need to type any command or stuff like that. This is especially helpful for the ones that are not developers, okay? So let's create our cluster, but first, let me show you that I have no cluster installed yet. Okay, no cluster. So let's create our cluster using the Create New button. And I'm going to expose my 80 port and 443, okay? And now create. While it's being created, you can see here at the Show Logs button, all the logs of the process going on in the background. Also, I can click here and type get pods to see all the pods being created. In a few seconds, you're going to see all the pods being created here, okay? And for this specific demonstration, I also selected the Envoy as my a way to expose my application externally using Ingress, okay? The community is thinking about using other tools for that, like Nginx, for example, is not available right now, but it's possible in the future. Right now, we have only Contour that uses Envoy for that. And now my cluster is being bit up, and it's ready now for me to use. As soon as you're ready, you're going to see that Podman Desktop selects for you automatically the context. In this case, Kind Cluster is the name of my cluster. And if I check here now, you're going to see that it created all the default pods for my infrastructure, for my control node here. And also it's creating now the Contour, and soon it's going to create the Envoy pod as well. It's creating now. While it's creating my default pods for my control plane, I'm going to create a container here, okay? So I can click here using Podman Create button, select an existing image, and I'm going to select, for example, this one HTTPD. It's very simple. I'm going to put a name at this container, HTTPD as well. I'm going to expose the 8080 port. I'm going to click here at Advanced, and I'm going to select to automatically remove the container as soon as I delete it as well. In the networking part, I'm going to put the host name of my container, HTTPD as well. And in security, I'm going to turn off security for this specific container. Simple as that. My container, it's going to be up and running now, as you can see here in the summary. Okay, I can check the logs for the container specifically. I can use the inspect button to see, using a Kubernetes manifest, all the information about my container. And if I go back here at my terminal, and I run Podman PS, you're going to see that I have a local container running in my machine, okay? So what I'm going to do now is deploy the same container that I have running in my machine into Kind. As you can see here, Kind is already working, okay? All the pods are available now, and I'm going to expose my container to my Kind cluster. Just click on this button here and select and create an ingress specifically for this container. And as soon as I click deploy, right here down the bottom, you're going to see the log and the manifest of this pod that is being created in my Kind cluster. Also, I can follow up here. The container is being created now, my HTTP pod container. And boom, it's running. Okay. Now, I don't need my local, sorry, I don't need my local container. So I can simply click here, delete it. So I don't have my container locally anymore. It's only available through my kind cluster. And I can click here in this Kubernetes dashboard. What I can see some information is about my cluster. How many pods it has, how many nodes it has. For example, if I click here nodes, you're going to see that there is a node specifically related to this cluster. By default, it creates this default node as a control plane node, okay? But you can create multi-nodes. You can create control plane nodes, you can create worker nodes, and etc. And now, as you can see here, my application is up and running. So just to show to you that I'm not joking, I'm going to curl my local host, and it works, okay? So if I don't need it anymore, what I can simply do is just go back here, delete everything like this. For example, I delete my ingress, I can delete my service, I can delete my pod down here as well. And finally, since I don't need this cluster anymore, I can delete it for good. So I can go back here at Podman Desktop, Settings button, Resources, click at the kind cluster, stop it. You are able also to stop and start your cluster as many times as you want. And finally, as soon as it stops, I'm going to delete it, okay? So as it's stopping, this is the demonstration real quick just to give you an overview on how you can work with Podman and Kind, okay, to streamline your process to create your application and test it on your own machine. That's it. Thank you.
Well done. A live demo in 5 minutes, and it worked. Cheers to you, sir. Next up, we've got Thomas. Okay, so Thomas is going to give us from black box to open book, leveraging open telemetry for auto documentation, auto documenting distributed systems. Bum, ba-da-da. And we golden, yeah?
Let me just get to this. Okay, 1 second. Move this over here. Oh, there we go. Okay, this is serious stuff.
All right, time starts now.
Okay, great. Where's my mouse? Uh-oh, okay. Okay, hi everyone. This is serious stuff, lightning talk. Okay, I'm excited to be here today. So first, quick question. Who here has heard of Observability 2.0? Show of hands. Okay, a few of you. That's great. Okay. A little bit about me. My name's Tom. I'm co-founder and CTO of Multiplayer. Multiplayer makes tools for teams that work on distributed systems. Many of those tools leverage OpenTelemetry. The goal of my talk is to spark conversation about how OpenTelemetry can be used to help teams understand their systems in new ways. I have 2 examples, auto documentation and platform debugging. As an industry, we've struggled to agree on the definition of the term observability. We tend to limit it to telemetry and monitoring. However, observability can be much more, and that's where the distinction between observability 1.0 and 2.0 originates from. Shout out to Charity Majors for coining the term. Quick overview, Observability 1.0 describes solutions closely tied to APM tools. At its core, it focuses on operations, highlighting issues once software is in production. Developers don't really like using APM tools for things like system documentation and debugging. There's too much data, it's not in the form that you need. You frequently have to search for a needle in a haystack, and because of sampling, many times the needle isn't even there. The term Observability 2.0 is meant to move beyond the typical DevOps workflows to empower the entire team throughout the software development lifecycle. Let's look at a first example of how you can use OpenTelemetry with an Observability 2.0 mindset. I'm sure we'd all agree that good system documentation is important, and yet we're still plagued by these problems. Why are we still doing this stuff manually? So here's a quick overview of a typical OpenTelemetry deployment scenario. We start with a platform. Once instrumented with OpenTelemetry, logs, metrics, and traces are routed through a collector to an observability platform. There are multiple ways to hook into this flow of data. You can generate trace IDs, specify span attributes, modify baggage. You can have a custom processor and a collector, and you can be a destination for the telemetry as well. For the purposes of auto documentation, we generate unique trace IDs, add information to spans, and we have a processor in the collector that makes us a destination for a small portion of the data. When we receive spans, we analyze them because there's a lot of interesting information. Where did my mouse go? Sorry. Anyway. Sorry, whoops. I've lost my mouse. Okay, let's go back here, little guy. Okay, here we go. Okay, sorry about that. I can still make it. I know I can still make it. So the system is a source of truth, and the docs are up to date and trusted, and you can do the same. Okay. Let me give you another example. These are common pain points I hear from teams debugging distributed systems. Why isn't it easier to report and fix bugs? For debugging, it's the same thing. We generate trace IDs and add span attributes. We add data to spans that allows us to correlate all the traces and logs for a debug session. We have a processor in the collector that makes us a destination for the data, and we put all the data in a debug session in a single place, so it's easy for developers to fix issues quickly. No more manually writing down steps to reproduce bugs, trying to reproduce those steps, or trying to find the needle in the APM haystack. So just like AutoDocs, this is something you can do as well. So just quick recap, Observability 1.0 and 2.0 are not mutually exclusive. They're complementary and serve valuable but distinct roles. Observability 2.0 represents a move beyond traditional DevOps workflows to include workflows for the entire team. And looking ahead, OpenTelemetry can be applied to many other use cases. We're working on others as well, such as automatic debugging. Think of this as like session sampling, and Debugger Gateway, which makes it easy for teams to develop and debug services in shared environments using just their IDE. If you're interested, let's chat more. Thanks for listening to my talk. I made it. There's a QR code. How was that?
You made it. You made it. 5 minutes. Boom.
Beautiful.
All right, so if anybody just came to the room and you're wondering what's going on, we are 5 minutes behind schedule with our lightning talks, but our lightning talks are hitting the 5-minute mark. So cheers to everybody thus far. So next up, we've got, how do you say your name?
Alex.
Alex? Oh, just kidding. We've got Alex with myths and truths about observability overhead. So take it away.
Okay, thank you. My name is Alex. I would like to talk about some myths around observability instrumentation overhead that I encountered again and again during something like a decade while working in the observability space. So first of all, what is instrumentation overhead? Let's say we have a function called process here that does some computing, and because of that it causes some latency. Now we would like to measure this latency, right? So we would use something like OpenTelemetry that we just heard about, the de facto industry standard for instrumentation. For that, we would inject some code to measure the latency, to get some metrics, spans, tracing, logs, and so on. But executing this code will also cause some additional latency, right? So the overall latency increases, and this piece that is marked in yellow here is something that the users would experience as overhead. Now that we have very roughly clarified what instrumentation overhead is, let's talk about some myths. First one, instrumentation overhead is the same as latency increase. I mean, it's true that latency is one form of overhead, but there are definitely also other manifestations of overhead. For example, increased resource utilization like CPU, increased memory allocations, or also network traffic increasing. Depending on the instrumentation type, whether you're using auto instrumentation or you're doing it manually, it can also have an impact on your startup time of your application. And finally, even the effort to put your instrumentation into your application can be seen as some sort of overhead, right? If you're doing it manually, it's more overhead than when you're doing it in an automated way. And the more important question is actually, or fact is that all these different dimensions are interrelated. So if you're improving one of them, you might be impacting another one. Let's come to the next one. Some people think like observability instrumentation can come for free. Actually, there's always some instrumentation overhead, right? It's like with Schrödinger's thought experiment with the cat. When you measure something, you also impact the system. So if you want a higher detail of instrumentation, that will come with a cost on the latency. If you want to automate instrumentation, it will very likely also impact the startup time of your application. And if you want to have reliable collection of your data without any loss, this very likely will also have some impact on memory or also network traffic. The more important question is, how big is the overhead, and is it acceptable for the value that it brings for your observability use cases? Let's come to the next one. Some folks think that auto-instrumentation and zero-code instrumentation is something like dark arts that will break and slow down your application. In reality, those agents and instrumentation agents that are used in the industry are being used by thousands of companies and millions of services. So those are battle tested, they are robust, and most of them are really designed for acceptably low default overhead. So it's usually quite safe to rely on auto-instrumentation and instrumentation agents. Yeah, my favorite myth is this one. One can make a general statement about the percentage of overhead that would apply to different applications. When you give a talk about observability, the first question is always, what is the overhead of an agent or something like that? Yeah, actually, the problem is it really depends. It depends on many things. First of all, something like the application size, the detail of your instrumentation, how you configure your agent and also your runtime, what is the load on your application, and what is the type of your application that you're running? Is it an e-commerce application or something like a high-frequency trading app? So there's actually no way to tell what is the exact overhead of an agent without knowing the very concrete context. And finally, there's the fear out there that auto-instrumentation is more expensive than manual instrumentation. I mean, that is partially true, especially when we are talking about auto-instrumentation that is applied at runtime. So this will impact your startup time of the application. But once the startup phase is over, basically the instrumentation stabilizes, and yeah, the overhead is comparable between auto-instrumentation and manual instrumentation. Okay, finally, let's talk quickly about how you can control instrumentation overhead. First of all, you have tools like sampling that allows you to reduce the data volume, and especially with instrumentation agents, doing something like head-based sampling allows you to reduce the overhead. With auto-instrumentation agents, you can also disable different instrumentation modules that allows you to fine-tune basically what data should be collected, and that also impacts the overhead at the end. In general, it's really a good idea to avoid fine-grained instrumentation. So it's certainly a bad idea to instrument something like a getter method that is being called 1,000 times a request. If startup time is important for you, something like in an AWS Lambda function, then it's really a good recommendation to use manual instrumentation, as it won't impact your startup time that much as auto-instrumentation. And finally, also try to avoid complex payload parsing at collection time. For example, parsing a huge SOAP message to get some information out of it is definitely not a good idea to do it during instrumentation. So that's it. Basically, don't be afraid to instrument your applications and don't get misled by the wrong myths out there about instrumentation overhead. Thank you.
All right, we need our next speaker up. And can we all just again give Benazir a round of applause for getting champagne to the lightning talks. I mean, what in the world? We get free coffee, like good coffee, right? Everyone saw the espresso machines. Water all day to keep us hydrated, for the champagne to kick us into the rest of the night. Not a bad way. All right, so next up we have Nicola, who's going to talk about deep dive into Gateway API backend TLS policy. And
I have to see where national.
are you?
Oh. Okay, I lost everything. Sorry. Okay, just it's not in the good way. Sorry.
Do we need AV?
It will be okay.
This is what happens when the demo gods win, the regular gods like lose. There we go. Yeah, they can't see me.
Oh, black magic, sorry.
Oh. Nicola.
Okay, I will have 5 minutes just to extend my screen correctly. Sorry for that.
Everyone drink up. This is what,
No,
the
I
champagne's
I
for.
lost everything. Okay. So let's do like that. Okay. Okay. So hello everybody. Let's start. So today I will show you in 5 minutes how to set up an end-to-end TLS connection with Gateway API resources backend TLS policy.
Yeah.
Yeah?
Oh,
Better like that. Okay, I'm Nicolas Mangin. I'm a maintainer of Traffic as the OSS Gateway Controller, and I'm working at Traffic Labs, the company behind Traffic. So what do I mean by end-to-end TLS connection? So TLS allows us to encrypt the data transmitted by the client, but where common architectures do the TLS termination on the gateway and use a non-encrypted connection between the gateway and the backend, an end-to-end TLS connection will ensure you that the connection is encrypted until the backend. It's very useful when you want to set up a zero-trust security architecture because you will ensure that you prevent any data breaches even inside your cluster. And on top of that, TLS is required for HTTP2 and gRPC connections. So how to do it? If you want to keep all the HTTP capabilities, such as the HTTP filters, for instance, you have to stay at the HTTP level, and you will serve a certificate on both the gateway and the backend. But in Kubernetes, we're used to using an ingress object to expose our payload. And even if the specification supports a way to serve a certificate on the gateway, there is nothing in this specification to establish a TLS connection between the gateway and the backend. And we have to use a vendor-specific annotation. Like here, I'm using a traffic annotation and a traffic custom resource. This is where backend TLS policy and gateway API come. So let's dive in the recipe. First, we need TLS certificates. I've created an external certificate served by my gateway and an internal certificate served by the backend. Both of them are stored in a secret, and I stored the internal CA. It's a CA route I used to generate the internal certificate in a config map. After that, I installed a gateway controller, and I referenced it using the gateway class. So I'm using Traffic. The third step is the gateway. The gateway allows you to define the entry point on your infrastructure. Here, I define a listener, an HTTPS listener on the port 8443, and I enable the mode terminate. It means that the TLS termination will be done on the gateway controller, and it will serve the secret external cert. The TLS certificate stored in the secret external cert. Next step is the HTTP route. The HTTP route defines the routing rules, and here, every request with the hostname wami.docker.localhost and the path /wami will be redirected to the service wami-tls on the port 8443. This service exposes a simple web server that is reachable in TLS on the port 8443. As you can see, we mount the secret internal certs to use the TLS certificate stored inside. And now, the backend TLS policy. Why? Because without this object, we will establish a TLS connection until Traffic. Traffic will serve the service, but it will establish an HTTP connection to the backend, and it won't work. But the backend TLS policy allows to establish such a connection between the gateway controller and the backend. It required a host name. The host name is the SNI the gateway will use. Okay. And of course, it could fit with the domain served by the domain the certificate on the backend can serve. I set a CA certificate refs to set my internal CA route. You can use a well-known CA route instead. And the backend TLS policy can target either a pod or a service. Here, I target a service UMI-TLS. Using a simple curl command, we can see that the architecture works. The client will establish a TLS connection to traffic. Traffic will serve the certificate, create an HTTPS connection to the backend, which will serve the internal certificates. You can find the slide and all the manifest flashing the QR code, and we can reach out during the KubeCon if you want. Thank you.
Hey, where's Yash? Oh, he didn't listen. It's okay. All right, how are you guys doing so far? Everybody good? Audience feeling good? All right, cool. So Yash is going to talk to us about multiplayer Kubernetes GitOps with friends. Everyone cross your fingers. Did somebody not cross their fingers? And we're money, sweet.
Hello everyone, I hope I'm audible. I'm learning British accent these days. I'm not sure how good I am. But yeah, this is first time in the London. So I have 5 minutes, I'll be quick. Today I will talk about the multiplayer Kubernetes GitOps with friends. The title is pretty, interesting. So I'll talk about a little bit about myself. So I'm Yash, developer advocate at DigitalOcean, and a maintainer of a project called Mishri. Mishri is a CNCF project. It's a sandbox project right now. So what is cloud native management? So we have seen that from the past 10 years, we have writing many YAML files, right? And it's been so many years that it's a so tedious task to debug those YAML files and writing those complex YAML files. And we are moving towards more of UI dashboards. So what Mishri is trying to solve is for you to provide a platform with a better user experience where you don't need to write any YAML file anymore. You can just use the facilities like drag and drop and create infrastructure for your Kubernetes cluster and in the future for your cloud platforms as well. So this is something how it looks like. So in this screenshot, you can see that there is a platform where 2 things are connected with each other. This is what we call design. We have some edges. So we call these as a component where you can drag and drop the pod, connect them with each other, and visually see your infrastructure. You can also connect your Mishri with existing infra, and it will show the visual interface of your infrastructure right now. You can go and use the Mishri on canvas.new as well. Mishri is multi-cluster management, so you can collect multiple clusters with your Mishri, and it also provides the context-aware design. So what context-aware design mean? Like, Mishri is intelligent enough to understand if a pod can make a relationship with service or not. If it will show you in the UI itself. I'll show you the quick demo as well. So yeah, I hope I don't miss anything. It also supports 200+ integrations. So if you go into the CNCF landscape, you will find so many technologies, and Mishri connects with most of them. So you will find most of them in the Mishri playground. So I'll show you quickly how that looks like. So this is how Mishri looks like, where I have my Nginx deployment and Nginx service created. I was having some issues with my Kubernetes cluster, which I have created on DigitalOcean. So, but I was doing that, but I will not be able to show you how it deploys, but I'll show you how that works. So in this one, you can see there is a pod which I created, which is the Nginx deployment and the Nginx service. And it is showing how both of them are created. Once you create them, you can configure them by clicking on it. You can give some information. And after that, you can click on actions and click on deploy. And that's it. It will deploy your infrastructure. You don't need to do anything else. Like, you can just click on this one, search anything which you want. Let's say namespace. I want namespace. Drag and drop. Give the name for your namespace and hit the deploy button again, and it will deploy for your infra. You can use the operator mode, where you can see the existing infra of your Kubernetes cluster as well. So for now, this is a design I created and published it as well, which you can use. So once you go to the canvas.new, you can click on the catalog, and click on the most open one, which is the Nginx deployment, which is created by me. So you can go ahead and you will be able to see this kind of your design in your Mishri, and you will be able to deploy it in your infra. So yeah, that's it. I'll go back to my slide. Okay. Okay. How you can start? Like Mishri is right now in the incubating process. You can go ahead and check out the Slack channel of the Mishri. Go do join. We'd love to have you there. We would love to talk with you. How was your experience? We are working on something which is great. We are working on towards solving the problem of complex YAML files. Do join us. Let me know. I will love to talk with you guys even after the talk itself in the Cloud Native projects. Thank you, everyone.
Big ups to all of our speakers, just keeping on time. So next up, we have Paul. Very difficult name to say, Paul. And he is talking about scheduling complex deployments across large multi-cluster test beds. Perfect.
Is that showing? One second, sorry.
How many of you? How many of you? This is your first Rejekts. Awesome. How many of you are local to London? Wow, so big ups to all of us coming from wherever to be here, and cheers to y'all for not having to come far. We're gonna make this work. Okay, how many first time? Hands up. Second time. Third. Fourth. Fifth. Sixth. All my 5-year people, raise your hands. It's awesome. Cheers to y'all. Are we good?
I'm not sorry, I'm having a bit of a blunder. Apologies.
No worries. This is a supportive room, and we had champagne, so nobody should care at this point. We are good. We are behind you.
Yeah. I can see my slides, just not my notes. And I've lost my mouse. Exit that. There we go.
Sweet.
Apologies, I'm sorry.
No worries. Note to self, you can do Google Slides on your phone, and you can get your presenter notes on your phone. Just, that's how I roll.
I'll make this in about 3 minutes then, just to catch up. So my name is Paul Power. I'm from Waterford, Ireland. I am in the EU research team. I'm currently working on EU Horizon projects. So the main project I'm on is P2 Code. So I'll just give you a little quick overview of what P2 Code is. It stands for Program Platform for Intelligent Collaborative Deployments. So it's essentially a developer platform for integrated CI/CD pipelines for creating cloud-native applications designed for deployment on edge devices. So just a quick overview of our responsibilities then. So essentially we're just responsible for the schedule, which I'll get more into a second, the resource manager, distributed storage, cloud controllers and drivers, creating OpenShift as a service on demand and keeping it dynamic, deploying OpenShift in different infrastructures, and then pulling telemetry data through Prometheus, extended through Murmur, and then centralized in an AWS instance to report that runtime data out. So the main issues we were facing with scheduling and how to kind of tackle these complex test beds across various locations in Europe would be cluster growth. So if something is hitting capacity, we need the ability to spin up a new one dynamically, but register it into the pre-existing test beds. Resource availability, we need to optimize resource management and scheduling intelligently, so it's not just going to bring up things constantly. performance as well, ensuring clusters aren't overloaded while keeping energy consumption as low as possible, and try to keep it green. And then within the application area specification requirements, so within the project there's 4 application areas, and there's 2 use cases per application area. And some of them have very specific hardware requirements for each, so it's important to know what's where at any given time. The real challenge here is just managing the workloads in a multi-cluster environment efficiently, ensuring optimal resource usage and low latency and high availability. So the main way we're doing that is with custom annotations and with node feature discovery. So, sorry, I think I skipped the slide. I did, I jumped over OCM. OCM provides, it's a powerful tool for managing multi-cluster environments, but we need more than just the basic scheduling that comes in the box with OCM. So with this, we're using the custom annotation features that is available by extensions and node feature discovery as well. So with the custom annotations, we can guide the system to make smarter scheduling decisions, optimizing for factors like locations, resources, and health of each cluster. Custom annotations and node feature discovery complement each other very well. The annotations enable us to fine-tune placement strategies, while node feature discovery supplies essential node-level information, such as the hardware capabilities available at each node, and then aggregate it back up to a cluster, so we know what's available on each cluster all the time. It'll give updates. I think we'd said it's every minute, so it's constantly up, and we know what's where. So the key benefits then, this approach leads us to smarter and more efficient workload placements, reducing latency and improving overall system performance. And by integrating OCM with custom annotations and leveraging node feature discovery, we can create a powerful dynamic scheduling system that improves performance, resource utilization, and reliability that can be fully extensible. So that's just a quick overview of the design. I'm not going to go through all of it now because there is a lot in it, but essentially we'd have an OCM hub deployed on each of the application area clusters. Underneath that, then there'd be the managed clusters under it. And then it essentially takes in the manifest work at the top level, which is then read by another partner's component and broken down into a separate YAML that is pushed back in with the set annotations in it, and then it determines on where it's going to push it out to once we have all the correct labels added in on each node. And that's just a group of the other people we're working with within the consortium on the project. And that's it. Thanks very much.
Thank you, Paul. And for those of you that are just joining us again, we are a little bit behind on scheduling, not because our speakers have gone over, but just because of some technical issues. So we've got Ingi up next, and he is going to give us the wise way to YAML. Thanks. He's got a pretty good title. You'll see it when you can see it. And we are good. Sweet. Let's go.
Let's do it. Hello. What if YAML files could include other YAML files or JSON files, because you know that JSON is a subset of YAML, right? Or CSV or TSV, XML, whatever, or specific parts of those files. What if YAML files could include data from the web, from a database, or any data source anywhere? What if YAML would let you do all the programmery things that you do when you're programming in YAML and still be a data language? What if you could use external libraries from all kinds of places, including WASM? What if there was a YAML loader library, like PyYAML for Python, in every programming language that worked the same everywhere, had the same features, was the most configurable, most secure, and actually correctly implemented the YAML 1.2 spec, which almost none do? What if it was a drop-in replacement for whatever YAML library you were using now? It would have to have the same peculiarities so that you didn't, they're all different actually, and you didn't break your users' config files. What if the YAML dev team made a new YAML 1.3 spec in 2025, and there was a fully working YAML 1.3 library in every programming language as soon as it dropped? My name is Ingi.net. I created the YAML data language spec starting in 2001 with a couple of friends. I lead the YAML maintenance team with 4 new friends, and we are planning the next spec. In the last 2 years, I've created the WISE YAML framework. So WISE is the new YAML engine. It's pronounced WISE because it's the plural of YS, right? WISE addresses YAML's problems and needs for everyone, not just for Kubernetes, not for just for Helm, for everyone that uses YAML. Learn about it at yamlscript.org. Your current YAML is valid YAML script. It will load with WISE. You can make it functional by adding a special tag to the top. All WISE code expressions, the programming parts, are 100% valid YAML. They have to be. And you have full control over what capabilities you allow your users to use out of those functional. It could be none. It could be actually less than YAML supports out of the bag. Fine-grained control. Okay, so let's look at a contrived example of a YAML file and another YAML file. So the one on the left is assigning some variables, pulling data from the web, loading data from a file, and selecting a random true or false. And the next document might include this pair that says maybe this pair will be included, and it's going to take 5 names from a giant list and print out a little letter. So let's see what happens. Okay, it didn't print that possible thing, but it printed out the nice letter from Daniette. Random numbers, there we go. So that random pair showed up. What would Helm look like if it had, instead of Go templating, YAML script in it? Well, let's take a look. There's a web page at yamlscript.org that you can see, control. It would look like this, about half the size and about half the width, and really tight. So everybody on the Helm team loves this, everybody in the last KubeCon loved it, and Matt Butcher personally loves it. He told me on the phone. Oops. I joined the Helm 4 team to make this a reality. So WISE loader libraries want to ship to 42 languages. That's my goal. 10 so far, but they're really easy to make. If you have a language that you'd like to see, let me know. WISE is also a complete programming language. If you go to exorcism.org, who's heard of exorcism.org? It's a language learning site for 75 programming languages, including YAML script. So there's some. So you can learn it there. Let's take a look at an example, 99 bottles of beer on the wall. There's the YAML program that prints that, and it takes a number, defaults to 99. Let's run it for 3 bottles of beer, and it works. And this is another program that does an API call. Let's just look at it. So this is all of the code that will post the list of files that follow the name as a GIST file, a URL that you can click on and see those files. It's tiny. And that's the end of my thing. But my last slide is here. So that was all I could tell you about this vast subject in 5 minutes. I hope you have hundreds of questions. And if you go to yamlscript.org/rejekts, you can find out how to contact me and ask me. Are you all this week? Please.
Thank you. Did anybody else not realize that we were with the inventor of YAML? Like, what? What? Y'all, clap it up. Like, 5-minute lightning talk. Like, thank you.
I think most of the Gen Zs didn't even realize it was ever invented, I think.
Us Gen Xers, we got to hold strong. Okay, cool. So, wow, that was eye-opening. Next up, we have Joaquim. Headlamp in, are you, oh, okay. And y'all, when I said sit in the front row, I was trying to make things better for all of us. Okay, we got you. Plug on in. Here you go. Okay, cool. All right, so Headlamp integrating external tools so you don't have to.
All right.
Well, maybe not. There we go.
Okay, thanks. Okay, so very quickly, I hope. CLIs are nice. I use them all the time, use them all the time, all that. They work in a very similar way, and every cloud provider has their own CLI tool, so that's very convenient. We can even say that it's the ultimate common interface, right? Because when you see some tool, you expect it to at least being able to run it in the terminal, if it's around, our little thingy here. However, they're not the most beginner-friendly choice. So they require the memorization of the commands, the syntax, how the parameters go. There's this lack of discoverability that that you have in these tools because you need to know what commands to use in order to use them, and it's kind of error-prone, right? So it's not a guided approach in conclusion, and I love CLI tools. I use them all the time. I never did anything like that. Yeah, so this is to say that we all agree that GUIs or graphical user interfaces are much nicer, right? So let's check Headlamp. So Headlamp is a UI for Kubernetes. It can run as a desktop application or a web application. It's vendor independent. You can run it with whatever flavor of Kubernetes you want. It relies on RBAC, so you don't really need to run it with a special permission, service account, stuff like that. And it's open source, and one important thing is that it's extensible through plugins, right? So what does this mean? And by the way, that's a whole video I'm not going to play, but what this means is that since the last version, you can also run CLI tools. So Headlamp has it's a browser interface. If you run the desktop application, we still have like the backend in it. And now we open the possibilities for plugins to run commands. And and so we have several plugins before we had this possibility. One of them was sometimes it was even tools that you have to run in the command line, for example, Compose here. But we had to find a way to run them, for example, in the browser, in the cluster. In this case, I need to run Compose, so I would create a job, Compose would run, and interface with it like that, right? So the logic had to run somehow in the cluster or in the browser. Since the last version, this is the right slide that I was trying to get to. We allow the desktop version again to run programs. So that means that sometimes you cannot run stuff either in the browser or in the cluster in this case. For example, let's say you want to create a Minikube cluster, right? You're not going to run that in another cluster. So right now you can do that. Of course, there's always a security implication to think of, and when you have a plugin that needs to run some tool, we do ask the user, do you want this tool to be run? Do you allow that? And so you can think that we do have a plugin for Minikube that provides Minikube, like I was saying, but the idea is that you can imagine like having stuff for example, cloud providers, so you can access, you can run their tools locally, and you can expose that as a nicer UI for the users. And that will hopefully make the project, make those CLI tools much more accessible. And check out our website. That's all I got for you. Thanks.
Thank you. Okay, next up. I'm terrible with, okay, how do you say it? Engin. Okay, sorry.
Ingi, but Engin.
All right, Engin, yes.
Okay.
So we got a fan club, this is awesome, fangirling, fanboying over here. MCPS in a DevOps world. Everyone, fingers crossed.
Yeah, let's see if it's working.
You got this.
Okay. Just a second, sorry.
No worries. Did anybody catch my shirt? Like, what's different? Like, what doesn't make any sense? Can anybody? That's so wrong. All right.
Okay.
And here we go.
Okay, you see, I'm using PowerPoint, I'm still old school. So AI, yay, AI, it has to arrive also here. So depending on your stand, you're either this fraction like, yeah, AI, it's all snake oil sellers and it's not cool. And maybe you're also the fraction of, hey, AI is here to stay, it helps me so much and so on. So independent of what you're believing, and I just want to show you something from my perspective, which I found very interesting, because I'm also looking, I'm not really jumping onto everything which is new in the AI space, but I found this Model Context Protocol, MCP, very, very interesting, not only because of the way and the things they're going to achieve there, or the possibilities we have now, but also seeing other people, the success. So for example, we saw some MCP servers connecting here to the Unreal Engine. I saw things with Blender, for example, so they connected the MCP server and then achieved things using natural language inside Blender or inside the Unreal Engine to create things. And then we saw also here with the releases here on the Cloud 3.7, the stars, if you take this as a vanity metric, but still it's really growing fast. And then also some random people on Twitter I just picked up who says, I'm going to build a PowerPoint automation for MCP. And now comes the biggest thing, which was for me an eye-opener when I saw the news from OpenAI when they say, hey, we're also going to support the MCP, which is, you know, standards. I mean, I'm from Europe, you know, we have USB-C and all the stuff and the plugs and the things, so getting standards is always difficult, and seeing here that OpenAI jumps also on the MCP protocol was really like, okay, that has to be. And then, of course, you have starting now seeing this GitHub repositories where people collecting some awesome MCP server examples. And then we see also that it's keep on evolving. So with the latest protocol version, they also tackle now things where we critical person are like, hey, how is it with security perspective and so on and so on. They're working also on this part. So we see OAuth authentication is there. So now I want to talk about MCPs in a DevOps world. So again, probably you're like, hey, what are MCPs? Okay, so that's from the official explanations say, okay, the Model Context Protocol is an open protocol that enables a seamless integration between LLM applications and external data sources and tools. And now we see with the DevOps world. So if you're really interested into this, I'm not that geeky enough to go through whatever lines of code for the JSON specification. This is the latest version. It's publicly available. Just quickly, how does it work? Yeah, we have our MCP host. It could be your IDE. It could be a tool. It could be an N8N or Claude desktop, and then depending on what you configured in your tool, it's going to start the MCP servers. There's a specification, SDK, how to build the stuff, and then interact with the systems behind through this unified protocol. So I can now talk with natural language with my Docker daemon. I can work on Kubernetes stuff. I can create GitHub accounts and all this stuff, commit data. Very interesting. So MCP introduces 3 key interfaces for data interaction. So it's tool prompts and resources. So tools are standardized actions declared on the server. So you can say, hey, please use kubectl, use Helm and whatever. Prompts, you can define prompt templates to interact, and then also resources, this unified way to access resources, be it data, be it files and so on. Okay, we now have a structured communication channel between AI agent and app and tools. So what are the benefits here? We can say, okay, we have now a discover capability of an app tool. We can interact with the app or tool through natural language, which is very, very interesting. We can retrieve informations from the app tool and execute commands. I always say app/tools because I'm more on the tools perspective as a DevOps person or platform engineering. So for me, it's more the tools perspective. How does it look like if we have a quick demo? Where are you? Where are you? So I opened Claude. I configured now a Kubernetes cluster. So you have to, on DigitalOcean, so if I say k get ns just as an idea, so to prove that it's working, hopefully, come on. Yeah, so we see that's the namespaces. So I can say, show me all the namespaces. This is really a stupid example, but 5 minutes. So, thanks for not taking this. Show me all the namespaces. I'm very not taking care of my grammar when I talk with LLMs. So now it asked me because yeah, it's here my demo environment. but here it goes now through the system, through the tool configured and create. So I could now say, create a simple Nginx deployment in a namespace called Rejekts. I didn't try this prompt, so probably it's not going to work. So it again, so it creates now the resource stuff. So let's say again, cloud get, yeah, we see the rejects one, and probably it's going to say car get, what was it all? Yeah, we see also an Nginx service is spin, no, it's not the one, so, okay. I'm horrible. I did this for the test, the commands with my muscle memory, and now I keep on forgetting them. So yeah, here is it. So it's spinned up. Okay, let's go back to the slides before I get the sign for 1 minute. So, okay, play from current slide. Okay, we talked about this. We saw the demo. So, I would say now in today's AI-integrated world, we have to accept the fact that we are now living in an AI-integrated world. So we should start off MCP-first approaches when we create new applications and everything. We should think about first make it accessible for the AI, for everything which is going to consume us. Before it was the human or it was REST APIs, now it's AI systems which is going to consume us. And this applies also for IDPs. So here I pulled up the capabilities platform from the working group of the CNCF around platforming. So where I would put this in now, I would completely replace the overlay and say, okay, now we can do this all with MCPs, we can provide templates and all this stuff. So maybe that's a substitution. Maybe it's only the GUI, the GUI part. I'm from Germany, GUI. Okay, and as you can see, there are also some marketplaces, so you can see there's much work going on. People start to work because it's that simple if you really look at this, so feel free to play around. They created many, many SDKs. I'm a Go user, so some people in the community, props to him, created the Go SDK. Yeah, we also, as this is top secret, you see from the sign, I should not show this, maybe I lose my job, but we're also working on implementation. And as a takeaway, so IDPs must be AI compatible and MCPs are the way to achieve this, and hopefully you play a little bit around with this. That's it, thanks.
Awesome. Arik. See, I love this. Front row, perfect. Everyone, fingers, please. So Kubeniks, declarative Kate workloads. Boom, look at that.
Hello everyone, today I want to present you a tool called Kubeniks, which allows you to declare your Kubernetes workloads fully reproducible. You can find the slides online by scanning this QR code. Let me briefly introduce myself. My name is Arik and I work as a senior software engineer at Sys11. If you want to reach out, feel free to contact me via any of these channels. In order to overcome limitations of flexibility and modularity of YAML, Helm templates those structures documents. However, this only mitigates some of its shortcomings while introducing other issues. I think this becomes pretty evident in this example. There's an awful lot of control structures here. There's even some validation going on during the rendering phase. You need to juggle with the indentation, and also the control structures span across many of hundreds of lines of code. I think we deserve better. So, Kubeniks can actually streamline the definition of complex application stacks. Kubeniks is built on Nix, which is a domain-specific language. It is a purely functional language, which is lazy evaluated. As a DSL, it is purpose-built, so you would not build like a real-world application out of it. Nix as a technology has the claim to enable systems which are reproducible, declarative, and reliable. Therefore, Kubeniks leverages so-called NixOS modules to define arbitrary Kubernetes manifests. In doing so, it enables modularity through inheritance and composability. Kubeniks basically implements an open API specification, so it brings additional type safety, during build time even. So let's have a small example of a web application. Since Nix is a functional language, every expression would be a function. This is how you would define a function in Nix, and with a let, you can bind local variables like an app, a version, or a host to a specific scope. You can also construct more complex types. Here we are inheriting the previously defined variables app and version into the attribute set labels. To define actual Kubernetes manifest, we are importing the corresponding Kubeniks module. and we can start defining our resources straight away. Our web application consists of a deployment, a service, and an ingress, each named by the variable app, so in this case, Nginx. Now, let's have a closer look at those three resources. To define a Kubernetes resource, we simply follow the usual structure of those resources. In this case, we define the spec field of a deployment. For the match labels, we can use the previously defined labels, very convenient. Those labels can be further reused by inheriting it into the template metadata field as well. So we now finally can define our container image, which basically reflects the app and the corresponding version. Let's move on to the next resource. The definition of the service is equally easy by simply defining its spec field. Again, we're using the labels as a selector, which ensures us that the service will always match the pods of the corresponding deployment. The pods are a list, which is also defined straightforward in Nix. We specify the protocol and port and are done for the service. Note that the port has a different type than the protocol here, which is a string. In contrast to Helm, this is actually type-checked. Let's move on to the last resource of our application. It is the ingress, and we can directly specify its spec rules, which is a list. We are inheriting the previously defined host from the variables and define the path as a list again. We want to match our request here, so we define the root path and use a prefix as a path type. Now we can select the backend service by its previously defined main, again ensuring that it will always match. And in less than 40 lines of code, we have defined a web application consisting of Kubernetes resources with minimal boilerplate overhead and additional type safety, ready to be reused elsewhere. Now, let's have a look how we can build and apply this. Here, we can simply use the standard Nix tooling and build the code, which I have just demonstrated. This gives us a V1 list, and those resources we can then inspect with any tool we actually want. So, or we can move forward and apply this to a cluster of our choice. So, wouldn't it be cool if we somehow could benefit from existing ecosystems dealing with packaging of Kubernetes workloads? Conveniently, kubnix also comes with a Helm module, which allows us to consume arbitrary Helm charts. Again, we'll define a function, specify the version of the Helm chart we want to consume as a local variable. Now, we're importing the Helm module and can start defining Helm charts right away. Therefore, we are fetching our Helm chart specified by its version and a repo URL. We give the chart a name and specify a content-based hash in order to satisfy the reproducibility requirement of Nix. Then we can directly specify any values which are supported by the Helm chart. In this example, we are setting the replica count to 2. This brings me to the end of my presentation. If you'd like to learn more, feel free to approach me or scan any of those QR codes. Thank you.
All right, guys, holding on fast. We've got 2 more lightning talks to go and then our closing. So we have got Philip. I love that you ran up here. You're amazing. Siegel Stateless OCI Registry. You were so fast, we didn't get to cross our fingers for you.
Why doesn't it want to?
You've got this. So I will say other places, when they do lightning talks, they make you put them all on one computer. So I appreciate y'all letting us make sure we can have demos and live content from multiple computers and holding on through these little minute technical difficulties.
Do you have any HDMI? Yeah, it's on the side. Pulled out the whole. Is it actually going to show up? I don't know.
There we go. It's popping up. Teamwork makes a dream work, y'all.
Resemblance of time. There we go. So I'm going to go really quickly now because we're over time. So yeah, I'm here to present Spiegel, which is a project that I've created about 3 years ago and I'm still maintaining. My name is Philip, if you didn't know. Yeah, so Spiegel is a stateless cluster local OCI register mirror. It's a mouthful and probably also very oxymoronic. So yeah, so out in the wild, we kind of see a lot of issues with image distributions when it comes to Kubernetes, especially it's more relevant now with rate limits, especially those like that have been introduced with like Docker Hub, but also like the K8s registries have like IP limits on like how many images you can pull with a specific IP. We see a lot of outages, GHCR, Docker Hub, Quay. It isn't really calling anybody out specifically. I think all registries out there are down sometime. Bandwidth limitations is also like a big thing, especially with like the free public registries. Docker Hub, I think, like limits you to like 100 megabits a second or something like that. But also like image removals. So we're building our cool applications. We're depending on images. Quay, like 2 years ago, had like a big cleanup of images where all of a sudden like Helm charts and images stored in Quay just like disappeared over the night. So about like 3 or 4 years ago, I had like a thought of like, okay, maybe there is like a better solution than just like running registry mirrors and like having all these stateful registries that we have to like deal with and like copy over images too. So I ended up building Spegel. For those who don't know, Spegel means mirror in Swedish. It basically just really allows you to pull images from other nodes. So what Spegel does is it runs as a daemon set in your Kubernetes cluster and basically runs a local registry. It then piggybacks on top of containerd. So an interesting fact of like containerd is when you're actually running a pod, the image that is pulled for that pod is actually stored on the node. So the disk space is already used. So what Spegel does is basically it runs a registry, reads the content that is already on disk, and then advertises it using a distributed hash table to all the other registries in the cluster. And then when a pod or an image needs to be pulled, containerd will first check with Spegel to see, oh, is there another node that already has this layer, and it will just redirect that traffic to that other node. And obviously then if it doesn't, it will fall back to the original registry. So it's like mostly like a best effort kind of cache. I've built like a lot of benchmarks. It's to see like generally like what kind of performance that we can expect from Spegel. Overall, like there are situations where Spegel performs poorly, and there are situations where Spegel performs like really well. Generally, I'd say somewhere between like 50 and 80% performance improvement is kind of what you see, especially with larger images is really like, especially with the AI craze and things, we see like larger and larger images. Yeah, like in general, like you'd see like a large performance like in pull time just because the locality of the images. So instead of going out to even ECR or ACR, pulling from within your like private network is always going to be faster. Yeah, so that's kind of it. Thank you very much. You can check out Spegel there. There's like the website to check out the documentation. There's also the GitHub repo. Yeah, thank you.